Alright, number 5, we want to know if this one is linear or not. And as you look at it, okay, there's no variables that have a degree higher than 1. Now there are 2 y's there, so that might give you pause because you only want 1 y, 1 x. But since they all have that first degree, this is not an x, this is a 5, sorry. This will be linear. Okay, so let's simplify it though, just so you can see. So you can have a number on the bottom, but you do not want a variable on the bottom. So for example, if we had, let me kind of squeeze this in. If we had like 4 divided by y, this would be essentially the same as saying 4y to the negative 1 power. So all your exponents needs to be a positive one, which they are. You couldn't divide by a variable, but you can divide by a number. So if you want to simplify this and get rid of fraction, instead of dividing by 5, you want to multiply by 5, and you got to do that with everything. So I'm going to multiply by 5 just to show simplifying. Multiply by 5, and then multiply by 5. So 5 will cancel out division by 5, so that would get rid of that term, and that will leave us with 9x plus y. And then 5 times the 4y will give you 20y. And then over here, 5 times 8 will give us 40. Alright, now at that point, we can add these two together, okay? And that will give us 9x plus 21y equals 40. And there you go. That's our standard form. And then you can see that it's linear. So if you can see just x to the first power, y to the first power, even if there's more than one, you will be able to simplify. As long as they're not being multiplied together, you'll have a linear expression. And then number 6, we're going to start doing intercepts. Okay, so we're going to find the x-intercept and y-intercept if possible. Okay? Okay, so our equation is 3x plus 8y equals negative 12. Okay, so I'm going to do two sides. I'm going to do x-intercept and the y-intercept. Okay, so here's what's happening. I'm going to show the full process at least once, and then I'm going to try to simplify it later on. So x-intercept, you have to remember the opposite one is 0. Y equals 0. That's what you have to remember. When you do the y-intercept, that means x equals 0. Okay. So the opposite one is going to be 0. I'm going to do the x-intercept first. That means y is going to be 0. So that means I'm going to do 3x plus 8y, but y is 0, so I'm going to plug a 0 in for y equals negative 12. Alright, 8 times 0 is 0, so when you add 0 to anything, it is itself. So you get 3x equals negative 12. It's negative 12. I don't know why I want to put a y there. Divide by 3 to get x by itself. 3 divided by 3 is 1, and then that leaves you with x equals negative 12 divided by 3 is a negative 4. So you want to put this as an order pair. X is negative 4, y is 0. So this is your x-intercept. Now, traditionally what I will do moving forward is I will just skip this step and just come right here. So whenever you want to do the x-intercept, I just get rid of the y term. Just cover it up, and this is the equation you're left with. 3x equals negative 12. And then I will do the same thing later on with y. When I want to plug a 0 for x, it's going to get canceled out, and I will just have 8y equals negative 12. But again, let's just show everything. So 3x is 0, so I'm going to plug a 0 here, plus 8y equals negative 12. 3 times 0 is 0. Add 0 to anything, it stays the same. So we have 8y equals negative 12. Divide by 8. And then you get y equals we're going to reduce this. Both of these can be divided by 4. 12 divided by 4, or negative 12 divided by 4 is negative 3. 8 divided by 4 is 2. So y is negative 3 over 2. When you put that as an ordered pair, x is 0. Y was negative 3 over 2. Be careful not to mix up the order pairs. Okay, the order is important. X, Y. Always in that order. X, Y. Alphabetical order. So here are our two intercepts. So x-intercept, negative 4, 0. Y-intercept, 0. And negative